Hi, in this video we will solve an example for finding area under the graph of a positive continuous function f of x equal to x squared on an interval 1, 3. Well, remember that we have to do 4 steps. Step 1 is divide the interval 1 and 3 into subintervals, equal subintervals. So A, B, then you do divide it into n pieces, equal pieces. x1 will be right and x2 will be right endpoint of the second one, and so on. Well, over there we know that the length of each subinterval, which we denoted by delta x, is equal to length of the total interval 3 minus 1 over, we are dividing it into n equal subintervals, so this will be 2 over n. And we have formula for xi. Xi is the right endpoint of the ith subinterval. So I subinterval has I interval before that, so that will be I, the length of that I subinterval would be I delta x, I of these delta x's, and then everything starts from A. In this case, A is 1 plus I delta x, we just found that this is 2 over n. So in other words, we have 2i over n. Step 2, area of ith rectangle. So here, we know that the area of a ith rectangle is going to be delta x f of xi. And that is 2 over n f of 1 plus 2i over n. Well, we know what is the function. This will be 1 plus 2i over n to the power 2. And step 3 is where we are done with this part. And this is sum of all the rectangles. Since we used n of them, so our n is what stands for that. And we know that this is given by 2 over n, 1 plus 2i n, the area of the ith rectangle, and add I from 1 to n. Well, that's the sum, but we can compute this sum. Why? You see, there is 2 over n here. I can put that out. Remember that the summing variable is I, and n is just a constant. And inside I have 1 plus 2i over n. I can expand that, get 1 plus 4in plus 4i squared n squared. All of this I goes from 1 to n. And well, to do the power n, we have a sum of I goes from 1 to n of 1s plus 4 over n is a constant, so I have 4 over n sums of I goes from 1 to n, plus of 4 over n squared, sum of I squared. I goes from 1 to n. And this number, as we did before in some examples, is going to be 2. Well, I'm using the formulas we have for powers of integers. This one will be 4 times n plus 1 over n. And this one is going to be 4 over 3 n plus 1, 2n plus 1 over n squared. And that's what we have for our n. This is the general formula. You got rid of the summation, and you have a formula only in terms of n. You see, this is an expression which has only n. Okay, before we do step 4, well, we can use now this formula. For example, find R any number, R10, meaning that the area approximated by 10 equal rectangles using right endpoints. This will be 2 plus 4. I'm just plugging 10 for n in that formula. So it will be 10 plus 1 over 10 plus 4 over 3, 10 plus 1, 2 times 10 plus 1 over 10 squared. Well, the numbers, I have computed this. Well, this is easy. 200 plus 440 plus 308 over 100. And if you compute that, it will give you 948. So that is just an approximation. We don't want approximation. We want an area. But I just want to show you how you can use that formula. Okay. Now the area, we know that this is a step 4. The area is limit of Rn as n goes to infinity. Yes. And well, in this case, we have limit of formula 2 plus 4 n plus 1 over n plus 4 over 3. Let me expand this thing here. This will be 2n2 plus 3n plus 1 over n squared as n goes to infinity. Okay, I have to find this limit. Well, if you don't like the way everything looks like here, you can change everything to x, and you will see that this is 4x plus 4 over x plus 4 over 3, 2x squared plus 3x plus 1 over x squared. Why did I do this? Because in this case, you will see that you have 3 limits, and you can find the limit of each one while knowing that each one is an indeterminate form of type infinity over infinity. And well, the first one not, so that's just the number 2. The second one is, and you can use L'Hopital's rule, this will give you 4. And then for the last one, you can use again that one, and this will give you 2. So the number you're looking for now is 6 plus 8 over 3, and that is 18 plus 8 over 3, which gives us 26 over 3. And you see this number is 8 point something, yes, 8.6666. And the number we found before for R10 is just a number close to that number, not exact number, but this is what we have for the area. All the 4 steps, you have to be able to form the formula for Rn and then evaluate it in some examples. And if you have the final value, then you find the limit. The limit will give you the area under the graph of that function.